Hola, hola. ¿Cómo es la calidad? ¿Bien, más o menos? Vale.
Hola, bienvenidos y buenas tardes. Hoy tenemos, siguiendo con la programación de charlas de empresa, hoy tenemos un evento algo especial, ya que coincidió la oferta que nos hizo esta empresa alemana, MaibornWolff, de una charla de temas de medioambientales, junto con que este mes de noviembre estamos celebrando el mes del medio ambiente en la ETSINF, con lo cual pensamos que era una ocasión excepcional para realizar esta charla. Tenemos el placer de recibir a Malte y a Jochen de esta empresa alemana. Esta empresa alemana ha abierto una oficina recientemente en Valencia y la verdad es que desde que han llegado aquí a Valencia están teniendo muy buena colaboración con nosotros y han realizado alguna actividad. El año pasado realizaron un seminario y por nuestra parte esperamos seguir colaborando con ellos. Y nada, nos van a dar una visión un poco diferente a la cual no estamos acostumbrados a tener tan en cuenta desde la universidad o desde esta escuela, que es los aspectos medioambientales del software y de la computación. Pues, danke. No puedo decir mucho más en alemán, lo siento. Gracias a Malte y a Jochen por ceder su tiempo y por venir. Bueno, Malte creo que ha venido posta de Alemania para dar esta charla. Jochen sí que está aquí. Y gracias también a la compañía por seguir colaborando con nosotros.
Vale. Gracias, César. También desde mi parte, bienvenidos y gracias por venir. Y de esta manera mostrar interés en el tema y también en la empresa. Voy a intentar hablar en castellano, no es mi lengua materna, pero espero expresarme y hacerme de entender. Antes de empezar, a mí también me gustaría daros las gracias por venir y dar las gracias a César por tener esa colaboración, mantenerla, seguir desarrollándola, que a nosotros la verdad es que es un placer estar aquí y seguir o establecer ese contacto y esa colaboración. ¿Qué vamos a hacer hoy? Pues estamos ya en medio del punto de la agenda. Después me gustaría explicaros o presentarnos a nosotros y también un poco de la empresa MaibornWolff y a lo mejor daros algunos ejemplos cómo pensamos, cómo funcionamos y a lo mejor cómo nos distinguimos también de otras empresas. Esto va a ser unos 10 minutos más o menos y toda esta parte va a ser en castellano, la voy a dar yo y luego la charla en sí, que es el motivo supongo que porque estáis aquí, el Green Software, que lo va a presentar Jochen, que llegó desde Alemania hace pocos días. Y esto va a ser aproximadamente 1 hora y después tenemos tiempo para contestar preguntas, pero en cada momento si pensáis algo, si queréis hacer alguna pregunta, sin problema, levantáis la mano y nos podéis interrumpir sin problema, o si no nos hacemos de entender por el idioma o lo que sea. ¿Se me escucha bien? Vale, gracias. Entonces, ¿quiénes somos? Yo me llamo Malte. En España suelo enfatizar que la letra después de la A es una L, porque si no se confunde fácilmente con Maite, que aquí no es un nombre muy común. Me incorporé en la empresa MaibornWolff en febrero de este año en la función de Software Engineer. Trabajo en el departamento que lo llamamos DC, que es de DevOps y Cloud Native, más bien con tecnologías de backend, pero también infrastructure, pipelining, cosas relacionadas con testing, y en el proyecto donde estoy actualmente trabajamos en Azure de Microsoft. Aparte de los 80% que dedico al trabajo de los proyectos, también tenemos una parte para hacer otras actividades, y esto lo utilizo en mi caso para fomentar la expansión en España y en Valencia. También hago partes de recruitment, y como por ejemplo esa colaboración con César y con la Universidad Politécnica de Valencia, también formo parte de ello. ¿Por qué hablo castellano y por qué me gusta España? Porque he estado en varias épocas viviendo aquí. De hecho, la primera vez que estuve en España fue en Valencia. Luego vivía y estudiaba en Barcelona durante un año con el programa Erasmus+, y el año pasado vivía en Alicante y trabajaba ahí de desarrollador mobile, de Android más precisamente. También, si queréis apuntar mi correo electrónico por si tenéis interés en poneros en contacto conmigo, es básicamente mi nombre Malte, punto, y luego el apellido, @ y el nombre de la empresa, MaibornWolff.de. Sí, esto sobre mí. Ahora voy a presentaros mi compañero Jochen, que llegó hace 2 días de Alemania. Se incorporó en MaibornWolff en junio del 2020 en la función de Full Stack Engineer. Trabajamos los dos en el mismo departamento, también es DevOps Cloud Native. Aparte de tareas de desarrollo, codificación, también tiene que ver con Continuous Integration and Continuous Delivery, cosas de tests y calidad. Y también trabaja en Azure y tareas relacionadas con DevOps. Aparte de las tareas relacionadas con el proyecto, también dedica tiempo en lo que es Green Tech, que tenemos como una community en la empresa. En ese contexto, hoy también estamos aquí para hablar de ello. También forma parte de crear contenido de formaciones internas, y también tiene su propio proyecto de investigación y desarrollo en la empresa. Jochen vivió y estudió en San Francisco, diseño y marketing, y luego ya se incorporó en la carrera de informática en Jena y Hamburgo, donde estudió el grado y el máster. También su contacto, que sería jochen.josbeck, nombre, apellido, @ y el nombre de la empresa. Vamos a hacer una excursión muy pequeña al idioma alemán. Me gustaría explicaros qué significa la palabra Mensch para nosotros. Si veis abajo a la derecha, en el icono de la empresa, en verde, también pone Mensch. Y Mensch significa algo como persona, humano. Y en nuestra empresa, esto es el foco de la atención. Casi todo se basa en los individuos, en los empleadores y las personas como tal. ¿Y qué significa esto? Pues he traído algunos ejemplos que me gustaría explicaros. En nuestra empresa no tenemos una cultura de trabajar horas extras. Trabajamos de lunes a viernes, no trabajamos los fines, ni trabajamos en horas que no nos vengan bien a cada uno. Y si en el caso que sientas que tienes que trabajar algo más, lo apuntamos todo y en algún momento podemos liberar estas horas. Si tienes ciertas horas acumuladas, pues liberas un día, o si son unas pocas, pues por la tarde, por ejemplo. No tenemos horario casi. Claro que hay que siempre tener en cuenta las prioridades del proyecto, de los compañeros, algunas reuniones importantes, pero en principio hay gente que le gusta levantarse pronto y empezar pronto, otra gente que le gustaría empezar más tarde. Entonces, con eso somos bastante flexibles. Si quieres hacer una pausa de más tiempo o menos tiempo, también puede ser. Si tienes una quedada privada durante el día, pues sigues trabajando por la tarde. Eso bastante flexible. Si eres una persona que te gusta también trabajar desde casa y a lo mejor ir mezclando el trabajo desde casa o desde la oficina, en nuestro caso también es posible, ya que tenemos ese concepto de trabajar remotamente aún más por la pandemia. Pero ya antes de la pandemia teníamos esa cultura. También para nosotros es muy importante que la gente que se incorpore pueda seguir formándose. Y para esto, cada uno recibimos un salario mensual al año que podemos utilizar para pagar formaciones internas o externas. Si sabes de algún congreso en el extranjero donde quieres ir, puedes pagar con ese dinero el vuelo, el hotel, las entradas al congreso y demás. Si hay algún tema que muy concretamente te interesa, tenemos, esto lo he mencionado antes, tenemos entre un 15 y 20% de nuestro tiempo que no tenemos que trabajar en los proyectos y que podemos invertir en cualquier otra cosa. Como por ejemplo, Jochen lo invierte en el tema de Green Software. Yo en partes lo invierto para estar aquí. Entonces tenemos ese margen que, digamos, de lunes a jueves trabajamos en el proyecto y los viernes trabajamos para lo que nos apetezca. Y si es un proyecto de I+D, también tenemos financiación por parte de la empresa para ello. Un ejemplo, al principio de la pandemia se creó un proyecto donde algunos ingenieros desarrollaron una máquina que filtra el aire para las oficinas, en filtrarlo en el sentido de limpiar el COVID del aire. Y lo publicamos todo open source, pusimos como las instrucciones, cómo construirlo, las partes electrónicas, el software, las impresiones 3D, y eso también es como un poco la aportación al bienestar general. Exacto. Si te falta algún equipo en casa o para el trabajo, para poder trabajar de manera más cómodo o lo que sea, puedes comprarlo, puedes apuntarlo y te lo reembolsa la oficina. Esto se basa en confianza, no tenemos ningún proceso que lo valide, eso cuesta tiempo, eso cuesta recursos, cuesta dinero. En nuestro caso se basa en transparencia y en confianza. Si quieres tomarte un café con uno de los gerentes, sin problema. Esto de hecho se le ofrece a cada persona nueva en la empresa quedar con uno de los gerentes, que tenemos 5, para comer juntos o para tener un café, simplemente para ir conociendo un poco su mentalidad. Ellos también quieren conocer a ti y así no vivimos la jerarquía horizontal, sino más bien vertical. Y todos estos ejemplos, que seguramente no han sido de todo completo, pero estos ejemplos también son un gran motivo porque desde el año 2010 solemos ocupar entre la plaza 1 y la plaza 3 entre los mejores empleados de Alemania. Hay como un concurso que se llama Great Place to Work, donde MaibornWolff siempre ocupa uno de las primeras plazas. Se fundó en 1989. Hace 2 años tuvimos un volumen de venta de más o menos 54 millones de euros. Actualmente somos alrededor de 700 empleados y tenemos 8 oficinas. La más nueva es la de Valencia, que abrimos hace 3/4 de año más o menos. Nuestra empresa actualmente tiene 13 departamentos operativos y 9 corporativos. Aquí solamente he puesto 6 ejemplos de los operativos para haceros una idea de tecnologías posibles que tratamos, que por ejemplo Cybersecurity, Data Science, Artificial Intelligence, Internet of Things, también Testing, Mobile and X-Reality, y el departamento donde Jochen y yo trabajamos es DevOps, Cloud Native, tecnologías cloud, cultura DevOps y demás. Con eso ya termino la introducción. Aquí otra vez la posibilidad de apuntar nuestros emails, si os interesa poneros en contacto con nosotros. Lo que sí que tengo que mencionar que para nosotros es importante el inglés, ya que es la herramienta principal de cómo nos comunicamos en la empresa y somos una empresa en el proceso de internacionalización, por lo tanto eso es importante. Ahora voy a pasarle el micrófono a Jochen, si no hay preguntas. A partir de ahora va a seguir en inglés y si queréis interrumpir en cualquier momento por si tenéis alguna pregunta, sin problema. Sí, gracias.
All right, now you can hear me. Thank you very much, Malta, for the kind introduction. As you already said, I will be talking about green software, and it's actually when I prepared for this talk, I realized that maybe sustainable software would have been a better title. But anyway, I think that the similarities are quite large between these two topics. So that's why I left it at green software. What is green software? It's basically the idea that we as software developers have an impact on our environment. And we will go into a little more detail about all of this and what it entails in the next 45 minutes to an hour, I guess. All right. Let me start off with a quote from Bill Gates. As a fellow computer scientist, he wrote a book about how we can deal with the impending climate disaster and how we can help to avoid it. And there are three main points that he makes quite early in his book, like page 8. He says that we need to get to zero emissions, and that entails all CO2 equivalent emissions. He says that we need to expand our wind and solar energy quite rapidly. And then third, we need breakthroughs big time. And I think that software will be part, at least, of the third bullet point here. Because, I mean, if we think about it, software is everywhere, and the use of software and technology is growing, especially when we think about developing countries and poor countries that are elevating their standard of living. They want to consume more, and especially more luxury products and conveniences like streaming television, streaming TV, movies, and TV shows directly through the internet, so video on demand, for instance. But there are many other applications where I think software use is going to grow. And oh no, wait, sorry, wrong thing. And this breakthrough, this is actually something that we can already see in software. So until a couple of years ago, when you wanted to visit someone or you wanted to have a meeting like I do now here, give a talk to you, you had to take an airplane or some kind of transportation, which is quite CO2 intensive, and you had to actually meet them in person. But now you can just replace that with an online call. And by the way, I didn't arrive here by plane, I came here by train, specifically because I didn't want to leave it too large of a footprint. But yeah, it took me about a day, but it was nice. I saw a lot of places in Europe. And this is actually one of the philosophies in green software. We call it green by software. So the software itself isn't what's green, but it's what you do with that software. And the other idea is green in software. And that's basically, you have software and it uses resources, like energy, for example. And it can do that either, no, wait, it can either do that quite rapidly, or it can do that not so rapidly, so that it will save energy and it will extend the battery life of your mobile devices. And we want to go from the left to the right, and we want to save energy, we want to save resources. not just energy. Green software is so much more than just energy saving technology. As I already mentioned, we have software everywhere, and not only are developing countries are going to use more software and more IT products, but also we as developed countries, we already use a lot of software, and we are extending that use, especially when you think about smart homes and smart cities. Your TV may be already smart, your fridge probably will be soon. We have smart thermostats, which already help us reduce our energy consumption for heating and cooling the living place, the home. But also in transportation, when you think about Teslas, for instance, they're basically computers with wheels. There's so much software in them for the driving assistance that it offers. And last but not least, we also have the Industry 4.0, which means that we digitalize more and more processes. We that way squeeze out a lot more efficiency of out of our processes, and we replace. So there are actually two ideas here: digitalization, which is taking a process and optimizing it through the means of IT and software. And there's digitization, which is you take analog things like paper, for instance, and you put it in a digital format. And that way you reduce massive amounts of waste. If you think back a couple centuries ago when you had to print everything and everything had to be on paper, and now you just have one device and you have terabytes of data and millions of pages worth saved on there. And that's going to grow. And with this growth comes a growth in resource consumption, which we can see here. This is an estimation of the energy demand for software or not just software, but information and communication technology in general over the next century, so until 2030. And you can see here that there's almost no line. Even the best case scenario is actually going up. And we are, by the way, we're far from reaching the best case scenario right now. So on the left here, you can see the energy need or demand in terawatt hours and the years on the bottom. Okay. With that in mind, there's whenever I talk to colleagues about this, there's always one topic that is coming up, which is the Bitcoin. And before I reveal the next slide, if any one of you want to guess what the Bitcoin network in general consumes in terms of energy, like compared it to a country, if you want to. Any guesses? Come again? Which country is that? Switzerland. Yeah, that's true. That was about 1 or 2 years ago. We are well past that point. New Zealand? Close. We are actually we're actually comparable to the Netherlands. This is from this morning, the most recent estimation that I could find. It's from the University of Cambridge. They have a website, and you can go in and check what they think the annual consumption will be. Yeah. That's just Bitcoin. So Ethereum will probably consume another big chunk, even though that will be reduced. I don't know when they release their new method, proof of state, but yeah. I mean, there are tons of cryptocurrencies out there, and Bitcoin's by far the biggest one. And if Bitcoin were a country, it would be a pretty big one. I mean, yeah, it's coming up on Argentina actually, which, I mean, it's one of the largest countries in South America. All right. But software alone does not produce any waste or any emissions, because there's no exhaust pipe on your laptop. There is no microplastic falling out of your cell phone. At least I hope not. The software itself doesn't cause any, but the hardware does. And whenever we think about software, we need to think about the underlying hardware. And there's actually been a great study which takes a view or a look on how the life cycle of software affects the usage of hardware, which then in turn affects the consumption of natural resources. So on the top here, you can see the different stages. And by the way, I really don't know why they didn't put an installation phase on there, because they have an uninstallation, but that's beside the point. I think the underlying message is still quite valid. You see the production already uses resources, because I'm a developer. I use my laptop to develop something. And this is especially relevant when you think about AI, because AI during its training is using a lot of resources, especially energy. Also, when you want to train a neural network, you usually don't want to do that on your laptop. You want to have specific high performance graphic cards or special hardware to train your network on. That again needs to be built and purchased, which is causing emissions and which is putting a strain on the environment. Well, then you use the software, of course. When I go check the latest news on my phone, I use that. That uses energy. The phone needs to be built, of course. And then at the end, we have the uninstallation, which actually has two effects. First of all, we need to probably start all over again, because you uninstalled that software to install a new one. It's quite rare that you do not replace uninstalled software with anything. That then also contributes to the disposal of hardware, because when you think about a new what's it called, operating system, that may have new hardware requirements, right? And you need to buy a new laptop or a new computer in order to fulfill those new hardware requirements. But you need to buy that new software because the old software is probably getting discontinued. That also goes in under the uninstallation. That's all pretty neat and all pretty obvious, but there are actually much bigger consequences here than energy and waste. And these effects on the environment, they can actually be categorized into three groups. You have the first order effects, which are direct effects. So the hardware, the software using the hardware directly affect the environment, because you need mining to get the precious metals and minerals that you need in your computer, which are, for instance, lithium for lithium-ion batteries, which is very bad for the environment. At least the mining is pretty bad for the environment. Lithium alone is quite common. But anyways, then you need the production, which again is quite energy intensive. You need big factories and concrete itself. I don't know if you know this, but if you want to make concrete out of some, or during the production of concrete, you release CO2. It's a chemical process, and you right now can't really avoid that release. Then of course you have the energy demand, and right now we are still burning fossil fuels in order to generate electricity. yes, we are building renewable energy sources like hydropower, solar energy, and wind energy. However, we're quite slow actually to build those. And when you think back, I said that the demand for software is growing. So will then be the energy consumption through that software. And that's, if you think about this as like a loading bar, right? You have a loading bar, and when the loading bar is full, will have reached 100% renewable energy. But when we add more and more demand, it's like extending that loading bar into infinity almost. Well, it seems like it right now. Okay, then you have the second order. The second order is indirect. Oh no, right. Sorry, I forgot the waste. Right now in Europe, at least, we have about a recycling rate of 45%. Just a very few countries in the EU fall under that threshold. And I think the next milestone should be 65-ish% of recycling rate, which isn't good because that means that over half of the gadgets and devices that you use will end up in a landfill, and there are some quite bad elements in there as well, not just lithium, copper, and gold, but also lead, cesium, chromium, which are toxic. And right, then you have the indirect effects. That's the second order. Through software, you can actually raise awareness. If you think about things like Ecosia, for instance, a search engine that lets you plant trees, and there are other examples of software having a beneficial effect in either the sense that it actually contributes to saving the planet, or it at least raises awareness and helps you make informed decisions on what products to buy or where to travel on your next holiday, or what services to subscribe to. Another indirect effect is increased productivity. As we already mentioned, the Industry 4.0, we do all of that digitalization to increase productivity, of course. And then you have the replacement effect, which I also already talked about. Then comes the third order, which is probably the hardest to get a grasp of, because those are long-term, usually indirect consequences. And most significantly here is the rebound effect. I also talked about the economic growth already. If we think about the developing countries, through the use of software, they will be richer in the future. Thus, they want to buy more, especially if you think about China right now. They're consuming more and more meat, and I'm pretty sure that you've all heard that eating meat is not as good for the environment. So yeah, that may be a consequence just out of the use of software, which is like 3-4 blocks down the road when you think about it. All right, and pollution, of course. We talked about that in the first order, but that's also a long-term effect. If you poison your drinking water with lead because you had a landfill next to your water source, for instance, that would be quite disastrous. And those are then generally rebound effects happen when you think about the telepresence and the online communication that I also touched upon earlier. What if you use that so much because it's so easy to use? You can just, I can just call my grandparents right now and see them live. Why shouldn't I do that every day? I wouldn't take the plane every day, but why not use my cell phone to talk to them every day? That actually would, over the time, create more and more emissions, and would create even, or could could create more emissions than taking a plane once a year. All right, so much for rebound effects. Should I keep using the wrong button? Now that we know that software has an effect, I want to underline how big that effect can be. And right here on this slide, we see different software products. The first two here, those are word processors. And because that question always comes up, I do not know which products are product 1 and product 2. I simply don't know. The authors of the paper specifically didn't mention names. But what they did mention is that one is a commercial product and one is an open source product. But I don't know which one is which. What I do know, however, because it's quite clear in this graph, is that obviously word processor 1 is using a lot more energy than word processor 2. And yeah, that is in watt hours, which isn't that much. But if you think about this, a company with 1,000 employees who all use word processor 1 for an hour will have produced almost 3.5 times as much energy need or energy demand as a company with 1,000 employees using word processor 2. Same goes here for browsers. Those three are browsers. You can see that the difference between browser 1 and browser 2 are almost a threefold difference. And the difference here isn't quite as big, but content management systems are very, very popular on the web. So if you want to have a personal website, you're probably not going to go in and code it yourself. You're probably going to use a content management system to do the underlying infrastructure for you, and you just put in your text, your images and videos and whatnot, and have the content management system take care of the rest. And then if you think about that, this really comes to, this is really important when you think about this in large numbers, right? Okay. And we build software to scale, obviously, so that's the whole point, right? We want a lot of people to use our products. Okay. Now, there are different approaches on how you can avoid ending up like word processor 1. And one of these approaches was introduced by Vautier, this guy right here. And he basically said, well, in a software product, I only want to have the functionality and the features that I really need. So it's basically just boil it all down to the MVP and don't build anything extra. That's what he means when he says requirement analysis. So, or maybe I should take a step back, right? So we've seen that software is a big problem in the future because it's growing. We're going to use more software. We also saw that software is affecting our natural resource, what's it called? Our natural resource demand. And we've seen that it does matter how we program our software and how we design it, how it then works on the metal, on the hardware. Because word processors or browsers, they're basically providing the same functionality, right? So they should also use about the same amount of resources. Now, when you are a software developer and you think about this, you're naturally going to ask yourself, how am I going to do this? How am I going to build green software? And I think this approach here from Vautier is a pretty straightforward approach. I would call it a practitioner's approach. Through these three criteria or ideas that you should, first of all, when you do your requirements analysis, only focus on the things that your users actually want out of your software and leave out all the extra features. So for a browser, all I want from a browser is it should display a web page, and I should be able to search for content. Actually, that's not something that the web browser needs to do, but when I type something into the address bar, it should lead me somewhere. All these extra features like bookmarks and the starting page so that I get some news when I open the browser, all those are extra features. And you can, of course, you're going to build that eventually. It's something called, something that we call the feature creep, that you start out with a very, very simple software, and then as time progresses, you add more and more features, which then, and because every line of code that you implement will be executed sooner or later, that will cause resource consumption sooner or later. So you will increase the need for resources here. Architecture and design is his next point. And he says, well, I can basically just, how do I explain that? Sorry. When you think about design, there's actually one thing that you can all do when you're working on a product, which is a dark mode. It's not difficult to implement, right? It's difficult to design maybe, but if you keep that in mind, a dark mode can actually decrease the energy consumption by about 30 to 60%. There's a great study by Dash that I recommend, and you can do so much more when you think about this. You can also design your softwares in a way that the user gets the things he needs the fastest, and that he doesn't spend unnecessary time on your software. Which is something that a lot of companies don't want to hear, because a lot of companies, they actually don't want you to close their app or their web page. Social networks are a very, very prominent example here, because they make money because you use that service for as long as possible. So they want you to stay as long as possible, but that's actually not good for the environment. And then, last but not least, we have the software level. Oh no, sorry, we had the architecture. I didn't talk about the architecture. So the basic idea here is that use whatever, or only use what you really need. So if you have a simple blog, for instance, you probably don't need a super elaborate architecture with tons of backups that allow you to have a SLA of more than 99.999%, and build your system in such a way that it only uses the resources you actually need. Right, but then last but not least, we have the software level, and here he says, well, you can optimize your code to fit your architecture, right? So this is not the architecture in terms of software architecture, this is the architecture in terms of hardware architecture. I don't know if you know this, but you have different kinds of processors, for instance. You have ARM processors, you have x86 processors, and they work a little different, and you can optimize for that. And you can also optimize your code. For instance, in general, single instruction, multiple data instructions in your code will increase performance and will reduce the amount of time a processor needs to finish a workload. So you should use that as much as possible. And there are many more ideas out there, which sadly is a little hard to find in publications, but there are static code analyze, what's it called, tools that statically analyze your code. And then they come back with some recommendations on how you can optimize your code, which is a cool thing. He actually said that in his paper, Woutier says that he had an energy reduction of 7% just by applying about 30% of the recommended changes to the code. And that's quite significant. And it took about a week. So if you think about that, if we could reduce the energy need of software by 7% just by doing a week worth of labor, that's quite good. All right. But other than that, there are more formal approaches. And these can be categorized into 4 different groups. The first is extension. And the underlying idea here is it may almost seem cynical at first, because the underlying idea here is, hey, we already have quality criteria like scalability, accessibility, performance, whatnot, and they already allow us, or they already, if we follow them, they already make us build green software or green-ish software. And so what you do is you take these quality criteria and you think about how does that benefit me in terms, or me or my software in terms of sustainability. Then you have the bottom-up approach. And the bottom-up approach is basically you come up with a bunch of sustainability criteria and you find groups and clusters, and then you build almost like a tree-like structure from that, and then you can optimize for those. He has done the top-down approach, which is, as the name suggests, the other way around. You look at the big picture, for instance, a life cycle analysis of the software, and then you drill down into those levels and come up with metrics and criteria on how to improve the sustainability of your software during that lifecycle phase. And then you have the combined approach, which takes any of the above and tries to take the best of all or both worlds. All right. I'm going to introduce just quite quickly one idea here. That's the extension. For instance, Albert Tau, he made a list. This is just an example, just one part of that list, and he finds, or he mentions how this, for instance, portability, the ability of a system to run under different computing environments, and he then says, what does that benefit me, or how does that benefit me, sorry, how does that benefit me in terms of sustainability or environmental aspects, and he says, well, if I can run it on different kinds of hardware, then I don't need to buy new hardware to run it, probably, and I can still keep my old hardware, minimizing waste, minimizing waste that way. All right, excuse me, I need to take a sip. Are there questions until this point? All right, no questions. Well, let's continue with the next approach. And I chose a top-down approach here because it's, I think, quite influential. This is the green software model proposed by Naumann and his colleagues. And the green software model seems quite big at first, but we're going to walk through this together. And at the top right here, you have this life cycle analysis. So this is reminiscent of what I showed you earlier, where you think about the development, the usage, and the end of life, and the three orders of effects, the direct, the indirect, and the long term. Then you have the sustainability criteria and metrics. And what you do is you first think about your software in terms of its life cycle. And you come up with ideas and effects in the first order, in the second order, in the third order for each of these phases. And you can add more phases if you think that that's relevant for your software. Once you've done that, you will come up with a list of or sets of criteria. And you have the directly related criteria. Those are criteria that that will help you fight the first order effects. The indirect related criteria metrics will help you fight the second and third order effects. And the common quality criteria, that's what I showed you on this slide here. Those are the common criteria, and there are many more. There's accessibility, there's performance, there's scalability, and many more. I'm sure you've heard of at least some of those before. And then after you have this set of criteria and metrics which you want to optimize, you then think about procedures. So procedures are kind of rules or guidelines on how you should develop, purchase, administrate, or use your software. So for instance, in the administrate part are guidelines on how administrators can optimize the energy efficiency and energy consumption of their data centers. And you do that, actually, let me use this one here. Looks much nicer than this mouse. So how do they do that? One example could be this what's it called? Plan, do, check cycle. I'm pretty sure you've heard of that. You can that way continuously improve your data center efficiency. On the development, we will get to that in a moment. On the purchase, procedures are ideas and ways on how to structure or how to do tenders, so that you also take into account sustainability from the get-go. So whenever you want to purchase new software as a company, for instance, you need some software that manages your storage facilities. You can go to different vendors and you can ask them, hey, how much energy does that consume in a standard use case scenario? And then you define standard use case scenarios. For instance, you want to, I don't know, take out one item of a specific category. How much energy would that require? And hopefully the vendor can tell you. All right, and then you have tools and recommendations, and that's basically just a list or guidelines again of things that developers, administrators, users, and purchasers should use. So for users, that's just very simple. Things like, hey, maybe you should check your energy saving settings on your computer. For developers, that's a little more elaborate. There are tools, for instance, as I already mentioned, that analyze your code and will give you ideas on how to improve that code in terms of efficiency and sustainability. But also there are tools that allow you to monitor the performance of your web page. So how much data do you need to load? And of course, the less data you need to load, the less strain you put on your network. And that way the network will use less energy. And you can also that way work with older networks. So you don't need to build a super fast 5G network across the country if your web pages only require 3G or 4G networks. Okay, with that, let's look into some of the. No, that doesn't work anymore. I need to click. Okay, this is what the use case, the lifecycle analysis could look like. This is just an example. But for instance, here during the distribution phase, you know that you will probably need to print some manuals. I know that's quite old school, but those manuals, of course, if you can find a way to avoid that by either making your software so easy to use that no one will, in the right mind, will ever need a manual for it, or by providing the manual online as a PDF to download, you can quite easily get rid of those effects. And yeah, there are many more effects depending on which stage of the life cycle your software is in. All right, any questions? Great. And oh, that's the same page. And this is the developer toolset. So this is corresponding to this here, the procedure model for developers. This is proposed by Naumann as well, and you here see a typical what's it called project going through its phases. So you have the requirements phase, the design phase, the implementation, and the testing phase. It's kind of this waterfall model. But if you think about this wrapping around here, so from the rollout back to the kickoff, you kind of get a agile-ish development lifecycle. So what they propose is that you have these sustainable reviews and previews every now and then during your development. And what you do here is you review what you've already done in terms of sustainability, and you preview what you can do next in the upcoming stages of your development. And you do that at discrete intervals. You also have the assessment process, which is a continuous thing that you have running all the time. You collect data throughout the entirety of the project. You analyze that continuously, and that way generate ideas that you can then evaluate in your preview and review meetings. And you have the sustainability journal, which is just there for documentation reasons. Because at the end, you're going to have the retrospective, which is kind of like a Scrum retrospective, but instead of how well do we work as a team and how well do we develop our stuff, you are here going to reflect upon how well did you do in terms of sustainability. And then at the end, you should have some kind of idea how to do it better in the future. And if you don't think of this here as a hard cut, but instead of wrapping around to the new feature, for instance, or a new sprint, then you can continuously improve your software that way. All right. Oh, sorry. That may seem very scientific and not very practical, especially compared to what I showed you earlier from Boutier, where he just says, well, you do what you can during your normal everyday developer routine. This here is a lot more complex. But it can get even more complex, which is this model right here, which may be a lot to digest, but we will go through this together. Down here, the yellow box, that's the hardware of your computer, which is split into 3 parts. You have the local capacities, so that's your smartphone or your laptop or your computer at home or your gaming console, for instance. You have transmission, which is the internet or some network. And you have the remote capacities, so that's a server or the cloud, which is basically the same. I mean, the server is just a bunch of, the cloud is just a bunch of servers. Anyway, and this has an effect on resources required for operation and required for production or disposal. This is very similar to what I've showed you at the very beginning of the talk. Now, these arrows here basically say it has an impact. So hardware has an impact on production, disposal, and operation. And then you can look at what is impacting the hardware. Of course, you have the hardware requirements of the software. That is pretty straightforward to see how that is impacting hardware. You have also resource management functionality. Now, what's resource management functionality? By the way, the blue bubbles up here, those are all things that are associated with the software itself. The green bubbles are associated with natural resources. The yellow, I already said, it's hardware. And the red are behavior and organizational. The gray ones, those are then what are called intermediate ideas or effects. Right, so resource management functionality. What's resource management functionality? Some of you may remember when you played games, you can usually select a resolution or an audio quality or a render distance in your games that you play. And depending on how you configure those settings, your hardware is going to be either pretty chill because you selected the minimum amount of settings and that way your computer won't need as much energy, or you can really put a stress on your hardware by having it all cranked up to the max. But that way you will also consume more energy, and if you want to play the most recent games, you probably will need some of the most recent hardware as well. And that way we come from here to here to here, because that new hardware needs to be produced. And that way you can go through this entire thing here. You also have support for self-directed management of the software. That would be things like, can I install add-ons on my web browser, for instance? Right. Any questions? No questions. Oh, okay. Now, for the very last thing, I want to leave you with what you can do, because this could all seem quite overwhelming, right? Especially when you think about this. No, sorry. Come on. This slide right here. That's a lot of things to do, and if you're just working on your own personal project, you're probably not gonna spend a month or so thinking about the life cycle of your software and thinking about some criteria and procedures and whatnot. That's just unrealistic. And also here you probably have to guess a lot or estimate. And that's why why I wanted to present you with some ideas. First of all, raise awareness. In your company, in your projects, the more people are talking about this, the more people are thinking about it. And I think the raising awareness here should not be underestimated. That's actually what I'm doing right now. I'm telling you that this may be a problem, and or that we have the potential to make a difference and help save our planet. That's also the next one. Take it into your project, and here it's really important to remember that everyone has a role to play, no matter whether you're a programmer or whether you're a product owner, an analyst of whatever flavor. You can all play a role in sustainable development. Right. Okay. And last but not least, we have research. That's actually why I'm here at the university. I'm hoping to get you excited because even though I've showed you some of the research already, there is still things that can be improved vastly. Especially if you think about AI, that I also briefly touched upon. Whenever, or more or less every other paper that I read about new breakthroughs in AI or simulation, they usually have a section at the end comparing the performance of their algorithm compared to others, right? And more often than not, I will find that their algorithm is more performant because those are the most interesting results, right? If you are better not only in accuracy, but also in the amount of time you need to train your model and to deploy your model, the more likely it will be to win against any competition. So that's one thing you can do. Just try to find a problem that you think you know a better solution for, and just go nuts. But other than that, there are many research questions directly related to environmental friendly development, green IT, green software, whatever. One of the things, for instance, is waiting, not waiting as in I wait in a line, but waiting in the terms of how should I prioritize my work. So for instance, let's say you are a product owner and a developer comes up to you and says, hey, I have two ideas how we can increase the sustainability of our software. Which one should I implement? As a product owner, you're very likely to just pick whatever is cheapest, but that's not necessarily what's best for the environment or what's best for sustainability criteria. And to have a way of factoring in this sustainability idea, I think that needs a lot more research so that we as practitioners can then apply those rules and yeah, find the best way to benefit. Right. Okay. But that's just one idea. There are many more, and if you want to hear more of them, I need to activate my laptop because that's where all my notes are. But for now, thank you for your attention, and if you have any questions, feel free to ask. I actually have some bonus slides prepared. If you have some time to spare, we can talk about how to measure energy consumption, because that's a big topic that isn't as easy as you think it is. Probably. I don't know what you're thinking about, but I'm guessing you just think about, well, you use a power meter and that's it. It's not that simple. All right.
Any questions? No? Patricia.
market of software, vendors and users demand or give more functionalities, and the quality of software is very related to give more.
Right. Yep.
So maybe in the framework of quality of software, it's necessary to add a new concept that is quality regarding like a footprint of your software, no?
Yeah, actually, that's one of the research questions. How can I label my software so that my customers can make an informed decision, right? If you think about products like fridges or washing machines, we already have labels for them in the EU, right? The A, B, C, D, E, F, G, I think that those are the labels. And A obviously is better than C or D. And having something like that for software would be great. And the other point that you touched upon is, yes, users demand more functionality and they demand more features. But thinking about sustainability and greenness of your software actually has more benefits than just environmental benefits. For instance, if you think about the dark mode example, right? By saving energy, your users can don't have to charge their phone as often, so the longevity of the devices is increased, which I think is quite a good example of how it's also benefiting the user, right? It's not just benefiting you. Other examples are, for instance, when you think about cloud technology, whenever you use some cloud resources, you're paying a price. And one part of that price is electricity. And if you can build your software in such a way that it uses less electricity, you can maybe use a smaller sized virtual machine, for instance, in the cloud. And that way save cost for you, which is, of course, again, another benefit that you get out of building green software. Right. Right. Exactly. Yeah. Yep. Yeah. That's one of the slides that I showed last. Let me go back. That's why here we have this configurability and the self-directed management aspect here. That the idea here is, yes, my washing machine can have 20-something programs, but I'm realistically only going to use 2 or 3, right? So the best case scenario would be for me that when I install that washing machine, I can choose which programs I'm probably going to use and discard all the rest of the programs. That way, these programs are not going to be bloated onto my washing machine device, whatever. So you get the analogy, right? It's a pretty bad example for a washing machine, but right. Yeah. So you, of course, you could go in and investigate which are the 3 programs that my users are going to use the most, and only develop those 3. But it's very unlikely, and to know upfront. It's very unlikely to know that upfront, and actually, it can be beneficial to have 20-something programs out there, because then the user thinks like, oh wow, I can really choose, and that choice is a big marketing, or has a big marketing effect, and then once you have the the customer buy your product, or once the customer bought your product, you can then have them configure it just the way they need it, so that it uses the least amount of energy. Of course, then you have the resource consumption during the development phase, but you will not have it during the usage and during the termination phase of your software, right? Mm-hmm. Yeah, okay, so the question was, I'm just going to repeat the question because I just realized that I didn't repeat yours, and for the recording that's not ideal. So let me paraphrase this. You want to know how to know when to stop developing in order to avoid this feature creep that I talked about, right? Is that correct? Yes. I don't have an easy answer for that. It's probably something that you could spend a lot of research on, but we already have tools like questionnaires or user analytics that allow you to look inside the brains of your users and figure out what they want. And usually users will tell you that they want more, right? As you already mentioned, users generally don't want to pay for less features. But then the question you should ask yourself is that really what my software is about? For instance, I think Facebook has their Instagram, no, sorry, their WhatsApp Messenger. You can post daily, what do you call this, like impressions of your life. I don't know the English word, I'm sorry. Where you can just a status like, hey, I'm doing so-and-so, and I'm with so-and-so, and I'm, I don't know, eating some sushi or whatever. Which is borrowed from, I think, Instagram or Snapchat that came up with this first, where you can just have your daily status updates. And you already have a software for that, right? You already have Instagram and Snapchat. You don't need to integrate that same functionality into WhatsApp, right? But they did it anyway. And that's a very typical example of feature creep. And if you think about when you ask your users and they come back with, I want daily features, then, I mean, I think even Instagram is part of Facebook, right? Yeah. So it's basically the same company doing the same thing twice. Yeah, if you think about that, maybe direct your users to your own product, which already does that for them, and that way only the users who want that functionality can install the Instagram app. All right? Does that satisfy you? Yes. Yeah, great, thank you.
More questions?
Very good question, by the way. Both of your questions were excellent questions.
Yeah, I have a question.
Yeah, sure.
A key factor in software is the operating system. Do you know if there are any studies comparing different kinds of operating systems, or according to these energy consumptions, something like that?
Not really, no. I mean, there are studies comparing different software products, like the one that I showed earlier, but I don't know of a specific one that compares those.
Theoretically, because most of them they are done to be run in laptops, so probably they should be at least
configured to be quite green.
Yeah.
But sometimes you feel some applications is like really they are not working very well. I don't want to put names.
Yeah. I mean, I don't know if you follow those, but the last, was it the last? Anyway, Apple announced quite recently their new generation of laptops, and one of the arguments that they had during the presentation was just how much more efficient their new M1 processors, or their Apple Silicon as they call it, how much more efficient that is compared to the competition. And I think they mentioned a 70% energy saving for the same for the same task, basically. So yeah, that you can do a lot with just optimizing for your architecture, right? If you know, I mean, Apple is in the unique position that they know how their hardware works, and they can optimize their software specifically for that. If you think about Windows, you can have an Intel processor, you can have an AMD processor, you could have an ARM processor. I mean, there's Windows for ARM, right? So it's a lot harder already, and then you have tons of graphic cards and millions of combinations, possible combinations from your memory, your main board, your motherboard, your CPU, your graphics card, right? So it's really hard to optimize for all of those, but yeah, it's an option, as Apple showed. It can be very significant.
So, if there are no more questions, thanks again for the talk. It has been really interesting, a different perspective that we never mentioned here, and we hope to repeat it soon.
Yeah, okay. That would be great. I thank you for having me. Thank you for attending, and I hope you have a nice day.
Okay. Gracias por venir.